Today let us try to discuss about network policy. What does it mean? Like, what is the intention of using this network policy? So if you go back, so by default, you know that every pod can communicate with each other, irrespective whether they are running on the same node or whether they are running on a different node. All the pods can communicate with each other. That's a general scenario which we know, right? Now we want to restrict that. Okay, so we don't want the pods to be isolated. Okay, sorry, we need the pods to be isolated. What are non-isolated? Non-isolated in the sense every pod can communicate with each other without any restriction. Now I want to add a isolation. So isolation in the sense I want to add some policy which is saying that a pod can communicate only to a certain pod, or a pod can communicate only to a pod which is present in a specific namespace, or a pod can communicate to a specific pod on a specific port number. So there are different strategies which we can apply, and we can say that whether this pod can communicate to other pod or not. That particular application is called as isolation using network policy. Okay, so we are trying to isolate the pod. The policy can be applied to the namespace level, pod level, and the port level. So these are the three things which we have to remember. You can apply a policy on the namespace level, which means that if you apply a policy on the namespace, all the pods within the namespace will get affected. Okay. If you want to apply a policy on a specific pod, then you can apply that as well. So in that namespace, only that particular pod will get affected. Okay, there is a third thing is nothing but if you want to apply policy to a specific port number of a pod in the namespaces to be restricted, then you can apply that as well. Okay, so these are the three different things which we have, and this network policy has two policies, actually major things. Okay, one is ingress and one is egress. Ingress in the sense incoming connection, egress in the sense outgoing packets. Okay, that's how it is. So these are the major things which we have in network policy: isolation and non-isolation of the ports. What does it mean, what network policy does, and what to whom we can apply this network policy. Okay, all these things are discussed in this paragraph. That is what I have explained right now. Okay, so let's go forward. So this is the simple example of ingress and egress of network policy. In one particular network policy, they have given the example. Okay, but we have to do lot of changes. In the examination, they might ask different scenarios. Okay, we have to understand the network policy file, then you can apply the changes according to the requirement of the question, actually. Okay, so see, he can ask in a single question, or he can ask in multiple questions like continuation. Okay, so we should always be ready for that. You might get one question or two questions from this. Maybe in CKA you will get only one question, but when you're writing CKAD or CKES, you'll get two questions from this. Okay, network policy. So yeah, let us see this example. Let us try to understand. The network policy API group is networking.kts.io/v1. Okay, this is the first thing. And what kind of resource we are trying to create on the Kubernetes cluster is nothing but object. We call it as network policy. Okay, metadata is nothing but name and to which namespace you want to apply. Okay, so network policy is a namespace level. That's how you apply. And the spec. Okay, here is where you will define your to which pod. See, what does it mean pod label? In the sense, in this namespace, it is applying this network policy to this particular pod. Okay, so this is what they are trying to say. In this namespace, when you try to create this network policy in this namespace, it will apply to this that particular pod in that namespace. Okay, that's how we have to understand. So what you are applying to this particular pod in this default namespace. Okay, I'm trying to add ingress and egress rules. Okay, what I'm adding for ingress rules, see there, from this IP block means everybody in this particular IP block, any pod in this IP block except this, okay, except from this network, okay, can communicate. That is the first thing. Okay, and they're adding the namespace selector, which means that in this namespace they want to communicate. Okay, they can also communicate. Okay, and then pod selector. So pod selector in the sense any namespace if a pod is communicating with this particular label, can get accepted. Okay, and the ports in this is only these port numbers are allowed, 6379. Okay, this is what it is talking about. Okay, so ingress in the sense, to this pod which packets are allowed in the sense to connect this particular network except this. Okay, and this particular network, this particular pods in this namespace, and this pod with this label. Okay, and that to which port number is allowed, only 6379. Okay, so this is what we have to understand. Egress in the sense, my pod to whom it can communicate. This particular pod can communicate to whom? It can communicate to the network called 10.0.0.2/24, and the port number which is allowed to communicate is nothing but 5978. Okay, only this port number is allowed to communicate. Okay, so this is what we have to understand. Only this particular port to allow, and this port number only to leave. Okay, so this is called as egress, and this is called as ingress block. Okay, we can write many from actually. Okay, you can write, it is up to you. Now let's go back. So we have this particular section explained. Spec network policy spec all information needed to define your particular network policy in a given namespace. That is what it is talking about. What are the mandatory fields for us? Okay, so the mandatory fields are API version, kind, metadata. Okay, so which you already know that. Then pod selector. Each network policy includes a pod selector which selects the group of pods or to which the policy applies. Okay, the example policy select the pod with the label. Okay, always we apply the policy based on label. So that is what you have to understand. How your network policy will be applied to a label, sorry, applied to a pod based on the label. Okay, so labels are mandatory for us when you are applying a network policy. Okay, every pod. So this particular pod called role DB. Okay, any empty pod selector selects all the pods in this namespace. Now let's say I want to apply this network policy to all the pods in this namespace. Then what you need to do? You need to write network or pod selector, and then you need to write flower brace. Okay, like this. Yes, you need to write pod selector, then you need to write like this. What will happen? All the pods in that particular namespace will get applied. Okay, if you want a specific pod, then you have to apply the label. Okay, that is what they are talking about, this particular parameter. Okay, it looks like this. Okay, pod selector. Okay, this section I am talking about. Okay, so after you have decided that it should apply to this particular pod in this namespace, then what we need to do? Then we need to go to the policy type. Do you want to apply ingress or egress? Do you want to apply the policy for the incoming connection or outgoing connection? That you have to decide. Once a decision has been made, then you need to write your rules for ingress or rules for the egress. Okay, ingress in the sense, each network policy may include a list of allowed ingress rules. Okay, so when you're writing the ingress, when you decided that your network policy type is ingress, then you need to write the ingress rules. It's how it looks. Okay, now, okay, so the ingress rule says that each rule allows traffic with matches both the from port section. Okay, so from port section in the sense, from all this pod IP block, network namespaces, and pod selector will get allowed to communicate to this particular pod on a port number only for 6379. Okay, so that is what it does. Okay, so each rule allows traffic which matches both the from and the port section. The example policy contains a single rule which matches the traffic on a single port from one of the three sources, which means that it allows only this particular port number. Okay, which means that this pod, okay, will accept only the connection from outside of this namespace, sorry, this CIDR block, except this and this namespace and this particular pod label. These three are allowed only to communicate through this particular port number 6379. If he is using, okay, same pod, if it is trying to use a different port number, it will reject. Okay, so that is what we have to remember. Let's say a pod is communicating from this particular CIDR. Okay, so it will allow only this particular port number to communicate, not any other port number from this CIDR block. Any pod from this particular namespace is allowed to communicate only on this port number. Any pod with this label is allowed to communicate only on this particular port number. So these two are like end operation. Okay, this is how it does. Now, a pod which is present in this namespace but is not having this particular ingress. Let's say, for example, what my question is, let's say there is a pod in this namespace. Okay, but it is not having this CIDR. Will it allow or not? A pod which is present in this namespace but it is not having this CIDR. Will it allow or will it continue? Any answer for this?
Not allowing.
Sorry?
Not allowing that.
It will allow.
CIDA
No,
range
no,
is
no, no. It
different.
will allow. It will allow the pod. See, my condition, I have already said that it should allow. Okay, if it is not having this CIDR or not, it will not care about it. Okay, if the pod is not in this namespace and if it is not having this label, okay, this pod selector label, and if the pod is not having this particular CIDR, then it will reject. Okay, what I'm saying, I hope you get it. A pod which is present in this namespace, for example, not present in this namespace, and it is not even having this label, and it is not having this particular CIDR as well, then it will reject. Okay, if the pod is present in either of these three conditions, either having this label or having this particular namespace, it is present in this namespace, or it is having this particular CIDR, it will accept. Okay, that's how it is. So the example policy contains a single rule which matches the traffic on a single port, okay, from one of the three resources. The first specified via a IP block, second via a namespace selector, and the third via a port selector. This is what we have done. Three sources. Now, egress policy. Each network policy may include a list of allowed egress policy. Each rule allows a traffic that matches both the two and ports. Okay, it has to match the two and the port. In this case, actually, okay, is allowed to go out. Okay, so example policy contains a single rule which matches the traffic on a single port to a destination in 10.0.0.2, sorry, 0/24. So the example network policy isolates this particular pod in the namespace, both ingress and egress traffic. That's how it is. Allows connection to all the pods in the default namespace with the label on TCP port 6379 from any pod in the default namespace with this particular label, any pod with the namespace of the label, IP address in this particular range. Okay, so that is what it is saying, except this particular range. Okay, so that is what it is saying. Allows connection to all ports in the default namespace with the label on a traffic on a TCP port called 6379 from any pod in the default namespace with the label this, any pod in the namespace with the label, okay, any pod with this particular label, role front end, where is that? Yeah, role front end. Okay, so so any pod in the namespace with the label this, IP addresses in the CIDR. Okay, so this is how it is applied. Okay, so in this way your network policy has been applied to communicate. Now allows connection to any pod in the default namespace with the label this CIDR on the TCP port 535978, which we have discussed. In this way, this is explained with a single example to cover all the topics. Now let's say I want to deny the ingress and egress rules both. How to do it? Okay, so all this example let us try to see one by one. Okay, let me try to log into my cluster and let me show you the examples. Okay, now what I want to do, I will not apply in any namespace, I will create two different namespaces. create namespace source. Mm, let's say, okay, I will write app1. Okay, I've created that app2 and then app3. Application 1, 2, 3, and let's say 4 also I created. So I've created totally 4 namespaces. So kubectl get namespaces. You can see there are 4 namespaces which I have created just now. I want to apply the network policy to this particular namespace. Let's say there is a pod running in that particular namespace. Okay, let me try to do that. So mkdir network policy. Okay, so first I will write scenarios. Scenario 1. Scenario 1. Okay, so what is that scenario 1 which I want to create? Sorry, I need to create a directory. What is the first scenario which I'm planning to? The first scenario which I'm planning to is I want to apply default block the incoming and outgoing packets in application 1. Okay, app1 namespace. So how to do that? So I'll write a simple pod YAML, or we can do it here itself. Let me do kubectl run. Okay, app1 hyphen pod1. Okay, and then I'm trying to create in that particular namespace. I will tell you in which namespace I'm trying to create. Okay, hyphen di hyphen image. I want to use nginx. Okay, and then in which namespace I want to create? I want to create in app1. Let it get created. What happened? Signal which? Okay, let me see. kubectl get pod hyphen n app1. It's running. Okay, done. So this pod is running right now in my namespace. That's fine. Okay, I want to run another application in a namespace called namespace2. Okay, so how to do that? Let's see. I think this is this is pod 1 only, but in app2 namespace. Okay, so since I want to write that, I need to write app2. Let's say application 1 only, pod 2. Okay, so in which namespace? Second namespace I just created. Now you can see it is running in another namespace. Now these pods can communicate with each other. Let's say, for example, if you go here, now these two pods can communicate with each other. Actually, you can execute ping or something. You can just check it actually. Okay, so we can use that as well. I could have done it actually. That's okay. Yeah. Now this pod is running, right? So if I go to this particular any one of them, so kubectl exec hyphen ti app1 hyphen pod1. Okay, in each namespace it is hyphen n app1. Okay, hyphen bash. I logged in. Okay, so now do I have ping command? I guess no. Okay, apt update. First I need to do that, and then apt install ip utils hyphen ping. Okay, done. Now what is the IP address? I just forgot. Okay, let me log in. I want to do this particular experiment on second pod, first pod as well, right? So in this namespace, I want to do. Okay, so same thing, I want to do an update on this particular pod as well. Update. apt install ip utils hyphen ping. Done. In both the pods, I have installed the required ping package. Okay, now if you see, this is one and this is another pod which I have, right? Now let me log into one of the pod. This is a second namespace which I have logged in, which means that in this namespace I have logged in. So I want to communicate to this particular pod. Is that possible or not? Let's see. If I run curl, it is there, I guess. You can see I was able to execute this. Okay, I'm getting a response from this particular pod. Okay, so now actually you can see this IP address is different actually. Slash etc. You already know this, right? This IP address is different, which is a second pod, which is running on a different namespace. Okay, now what I want to do. So if I log into another pod, you can just communicate, no problem at all. There also I can run update command. Okay, curl. If I want to run this on, I want to check the pod again. Okay, this is the IP, right? So let me log in. Now if I run curl, it works. Okay, so both are able to communicate with each other. There is no restriction at all. That is what I have told by default. It is non-isolated. Okay, now I want to apply an isolation, which is nothing but every pod should not communicate each other directly without any verification. So for that I want to isolate with each other this particular pods, and by applying a network policy. Okay, so how will you apply a network policy right now? Right now I will apply a deny rule. By default, deny all the incoming packets and incoming packets only for that particular second namespace. Okay, so which namespace I want to apply to this actually? Oh, come on. I want to apply to this particular pod. Okay, so that is my intention. To this pod, I want to apply a network policy saying that any pod in this particular namespace should not accept the incoming packets from anywhere. Okay, so how to apply that? So to apply that, we need to write the same thing. Let me just copy this. Okay, deny for what? To whom it is add to. Okay, namespace. Okay, so that's the reason I have written like this. Now what you need to do is nothing but you need to block only incoming, right? So then you want to apply to all the pods in this namespace, right? Which namespace you are trying to create. So then you need to remove this and you need to write only flower bases, right? That is the first thing. And here you need to write which namespace it is. So I want to apply to add to. Okay, so this is add to network policy. Okay, now here what you need to write. Okay, so here you need to write like this. If you want an example of it, default deny all ingress rules. Okay, you need to write like this. Done. We have followed that, and you are trying to apply some namespace. That is also we have specified, right? So then remove this. Okay, now save this. Okay, if you see the default deny and default accept, okay, both will be like a slight difference. Okay, default deny, right? Default allow, if you see, just you will add this one. Okay, if you add this section, it is going to allow all. If you don't write this section, it will same YAML, same example, but you add like this. For example, same file, if I open and if I write like this, sorry, let me show you. If I write like Ingress, you can see there it is a small letter, right? You can see small letter. And just writing a flower base, that's it. You can see there. Okay, just writing a flower base. Okay, now this will become as a default allow. Okay, so that's how it is. So let me try to remove this. I want to apply a deny rule. So now just save this and apply. kubectl create -f default. Now I apply to this particular namespace to all the pods, which means that if I log in from app1 namespace any pod and if I try to run curl on this particular IP, it should reject. Okay, now this policy is applied. Let's go and log into that particular pod. I logged in, you can see there in the app1 namespace. Now if I take this, let me take this, and if I try to run curl, you see I'm not getting any response. Okay, this is denied. By default it is denied. Any pod which is running in app2 namespace, it will reject. It will reject the incoming packets. It will not. But you have rejected only incoming packets. But if you log into that pod in that namespace, okay, if I log into this pod in this namespace, I can send the packet. That is allowed for me. Okay, I can do that. See, I was able to send the means I'm able to go out, but I'm not allowing anyone to reach my pod. That is called as allowing on denying ingress rules. Egress rules will activate, means like that will be available, no restriction on that. If you want to block this one as well, okay, if you want to block this one as well, then you need to apply egress rules. Same example, where is this? Yeah, same example, you need to write just hyphen egress. So both incoming and outgoing packets will get rejected. Okay, for that, if you want to see the default egress deny, you can see this. If you don't want to allow income ingress and egress, you need to write one more section related to hyphen ingress. That's it. Both will be applied. Okay, let me show you that. Okay, now I will use the same network policy. Keeps it here. Get network policy np. I created in which namespace? Okay, network. So network policy in namespace called app2. Okay, it is applied, right? So let me try to do an edit. Sorry. Okay, now what I want to do, I want to block egress rules as well, means outgoing packets. Okay, done. Now, if I go to the pod which I logged in earlier, I used to able to run this curl command, right? Now you see it is not allowed. Earlier I was able to run the curl command to that particular pod. Now this is not allowed. Okay, so in this way. So from this particular pod in this namespace, it will not allow the outgoing rules. It will not allow the outgoing packets and incoming packets are both are blocked. Okay, so that's just how it is. If you want to do like this, you have to do like that. Okay, so let me try to do an edit. Let me remove that particular section. Okay, now let me remove the network policy. Okay, I don't want this to be happen. So delete hyphen f. Network policy. Done. Delete. Oh, spelling mistake. Done. So now if I log into this particular pod, sorry, if I log into this particular pod and if I run the curl command, it works now. Why? Because I removed the network policy itself. So now both incoming and outgoing packets are allowed without any issue. Okay. So this is the first scenario we have seen. How to apply deny rule for ingress and egress. A combination of both as well. Okay. So four topics are covered at a time. Deny all ingress, deny all egress, deny all allow. Means I have not shown this, but you know this. Okay. It is so simple. Okay. By default it is allowed, right? No need to explicitly write this. Okay. This allow one. Now let us do some experiments. Okay, I want to apply this network policy. Pods which are running in app1 namespace should allow only the communication only from app2 namespace. If you are trying to communicate from app3 namespace or app4 namespace, it should reject. Okay, that is my requirement right now. Okay, so this is second scenario. So let us try to see the second scenario. So mkdir scenario 2. What is the second scenario? Let us see. So I am writing some policy. Okay, app1 to app2. That's it. So that I can look at this and understand how to write that. I'll just copy the example from here. Let's say I will do some modifications. Okay. Okay. Egress rules we are not adding. So just remove this section. So we are not adding any egress rules right now. Now let's go back to this. Egress rule is not allowed. Okay, only ingress. To whom what we need to apply. So this is nothing but app. I want to apply in app1 namespace. Okay, to policy. So this is nothing but app1. Okay, in app1 namespace, I want to apply to all the pods. So I will remove this one. Okay, again, all the pods in that particular namespace called app1, what they need to do? They need to allow only incoming packets from whom? From this particular namespace. So IP block is not needed for me. Okay, IP block is not needed for me. I need to apply this. So before applying this particular network policy to that particular namespace of app1, how will you apply? Based on the name of the namespace? No. We need to have some label to that particular namespace. Okay. So what is the label? Let me try to add. So kubectl get namespaces. Okay. Now if you want to see the labels, hyphen show hyphen labels. You can see there are from some predefined labels which are added. Only the name whatever we are using. I want to add some particular label. Okay. So what I want to do is nothing but I want to add a label to my namespace. Label name space. What is that? App1. So here I want to add something like application is equal to app1. Okay. This is what I want to add. For app2, I just want to add this app2. Simple. Okay, I'm not adding too much complex labels as well because we need to understand the concept. I'm adding for all the pods, sorry, all the namespaces. I'm adding this name labels. Done. Now if you look at this, now you can see additionally we have other labels as well. App is equal to app1, app is equal to app2, app is equal to app3, and app is equal to app4. That is what I have written. Okay, now let us open this network policy which I am writing right now. So I want to apply to a namespace with the label called app colon app2. Okay, which means that I want to allow the pods, all the pods in this particular namespace. Simple. Okay, any restriction on the pod? No, I don't want to allow. I don't have any restrictions of a specific pod, so I don't want that particular restriction. Do you want to allow only a specific port number? No. So I want to allow all the port numbers, so I don't want this as well, right? So what this particular rule is talking about is nothing but I'm applying a network policy to the pod in the namespace called app1 to all the pods in that particular namespace. What I'm allowing ingress rules from this particular namespace which is having a label called app2. Okay, this is what I'm doing right now. So applications are already running. So let me try to do the experiment. Create -f network policy. Done. Okay. Now if I log into the app2 or app1, or let's say ingress, right? So I need to log into app2. So I want to log into app2 pod. Okay, I logged in. Okay. From here, if I run the curl, it works. Though you applied network policy, you allowed it actually to communicate. Now let me try to create another pod in that particular different namespace. That is app3. An app3 namespace. Okay, I created. Now if I check that kubectl get pod hyphen o wide. Nothing to see actually, but I just want to show. Where is that? Oh, sorry, app3. Okay, it's running. Now I want to communicate from this particular pod. From this particular pod, if I try to run curl, it should reject. Why? Because all the pods in that particular namespace called app2 is only allowed to communicate to my application called app1. Okay, app1 application or IP address is this actually. Okay, let's see what happens. Okay, if I try to run curl on this, oh sorry, I think yeah it works. See, now you can see it is not working. Why? Because it is rejected. Only from this particular namespace, any pod in this particular namespace called app2 is allowed. But your pod is running in app3 namespace. Is it allowed? No. That's how it is. In this way, we can apply our network policies. Okay. This is only just a few examples which I've shown. Tomorrow, what we can do is nothing but we can add some more logics to this. Okay. So today I just want to split into a basic one. So that's the reason I took some examples of deny rules and deny rules actually, default deny and default allow rules. Okay. Now I took some sample example by creating 4 namespaces, one application in app1 namespace, one application in app2, and one application in app3. So when I applied a network policy in app1 saying that app1 namespace should allow only the pods which are running in app2 namespace. So that is what I have done. It is working in above example. Now when I created some application in app3 namespace, and from there if I am trying to communicate to app1, it is rejected. Okay. So this is how it is. If you want to allow from app3 namespace as well, so what you need to do, you need to modify the network policy. Simple. Okay, you need to change that. That is what you have to do. So what you need to do, here you need to add another namespace section. Okay, so how will you add it? Or you can just yeah, 1 2 3, right? 3. Okay, here I need to add app3. Okay, so now if I apply this change, see, kubectl apply -f, sorry. Okay, warning. Anyway, it is warning, but fine, it got applied. Okay, so how will you observe that? Now if you log in and if you re-execute this curl command, it worked. Now it is worked. How? Why? Because I allowed. I accepted in my network policy saying that even from app3 namespace also please allow the pod communication. Okay, that is what happens. If you want to allow a specific pod in a specific namespace, tomorrow we will see that particular experiment. We will create multiple pods in multiple namespaces, but one with 1 or 2 pods in each and every namespace, and then we will see how to add restrictions. Okay, so that's how we do. So this is a basic way to start with. This will be really helpful for your examination when you're writing for CK or CK80. Just understand the requirement and try to apply that network policy. It all depends upon understanding only. Major part, 90% of the job will be done through understanding the requirement. Applying that policy is not that big. Okay, so just you can take an example, modify the parameters, done, apply it. Okay, check the experiment, do the experiment and see whether it is working or not. Okay, it is not that tough as we think. Okay, yeah, that's all for today. So tomorrow we will continue with the rest of the scenarios. We have so many scenarios actually. That's the reason it will take 2 days to complete. Okay, thank you.